Find the derivative of y equals f of x over g of x by applying the product rule and chain rule. The product rule says that if y is the product of the two functions f of x and g of x, then dy by dx equals f dashed of x times g of x plus f of x times g dashed of x. And we recall that f dashed of x means the derivative of f of x. The chain rule says that if y equals f of g of x, then dy by dx equals dy by du times du by dx, where u equals g of x, so that y equals f of u. And in this case, y is called a composite function. And so to apply these rules to this problem, we have to rewrite the quotient as a product and a composite function. And a quotient means the result of a division. And so here the quotient is the quantity f of x over g of x. So we take y equals f of x over g of x, and we factor it as f of x times 1 over g of x to produce a product. And we rewrite 1 over g of x as g of x to the minus 1, which will be our composite function. And finally, we turn this into f of x times h of x, where h of x equals g of x to the minus 1, which equals 1 over g of x. And so by applying the chain rule, we have that dy by dx equals f dashed of x times h of x plus f of x times h dashed of x. And we rewrite h of x, which equals g of x to the minus 1, as u to the minus 1, where u equals g of x. Now we need to find h dashed of x, and to do so we apply the chain rule to h of x. And so we have that h dashed of x, which equals dh by dx, equals dh by du times du by dx. Now h equals u to the minus 1, so dh by du equals minus u to the minus 2, which equals minus 1 over u squared. And since u equals g of x, we have that dh by du equals minus 1 over g squared of x, where g squared of x means g of x times g of x. Also, u equals g of x, so by definition, du by dx equals g dashed of x. And so with those two results, we have that dh by du times du by dx equals minus 1 over g squared of x times g dashed of x. So that h dashed of x equals minus g dashed of x over g squared of x. And so making the following substitutions in the expression for dy by dx, we obtain this expression, which simplifies to this expression, and on putting the two fractions over a common denominator, we obtain g of x times f dashed of x minus f of x times g dashed of x all over g squared of x. And so by applying the product rule and chain rule to the expression f of x over g of x, we have that if y equals f of x over g of x, then dy by dx equals g of x times f dashed of x minus f of x times g dashed of x all over g squared of x.